some extent even biology. These tools of science, as I said, covers, physics, which is encapsulated in what we refer to as geophysics. The geoelectric method, the seismic, gravity, magnetic, and what have you. Using all this now, forms the
We cannot hear you, sir.
You cannot hear me. Oh, is it my network?
No, probably the earpiece.
We can hear you now.
Okay.
We can hear you now. Yeah.
Hear you.
Okay. Okay. Thank you. So using these tools to look for mineral deposits is what is referred to as mineral exploration. But how do we look for mineral deposits if we do not know the environment where we can find the mineral? If we do not know how those minerals are formed? If we do not know how to identify the minerals? That is to say that we need these three things before we go into mineral exploration. So professionally, for anybody to go into mineral exploration or to call himself a mineral explorationist, the person needs to know these three things. First and foremost, you need to know how to identify the minerals. You need to know how to know them, because if you don't know them, how will you locate them? Then two, you need to know how they are formed. Knowing how they are formed will best give you an idea of how you can locate them. That is, and of course, that is exploration. And then knowing how they are formed also relates to knowing the environments at which they can be found. Because there are certain environments, if one maybe chooses to look for a particular mineral, the person is just wasting his time. So one needs to know which environment is for which and why and what. That is why only geologists can take up mineral exploration. I have had an instances where I've seen, several surveyors, several engineers going into exploration. It won't work because somebody needs to know how the minerals are formed, how to identify the minerals, and of course the environments where the minerals can be formed before even going to the field. Then it is when you go to the field, you now apply those tools, scientific tools for the exploration, the geophysics components, geochemistry component, even biogeochemistry, and many more. So because of these three components which I have mentioned, it is what actually gave me an insight. It is what informed the choice of my topic, which is from metamorphism. Can you go to the next slide, please? From metamorphism to mineralization. I asked myself, okay, maybe we can go to the next slide, please, if you can hear me.
Yeah, you're on the next slide now.
All right, next again.
Another one?
Yes, just click, okay. Yes.
This one?
I have a figure on the right side. Yes, this figure.
Okay, yeah.
Yes, thank you. So for us to understand, though there are so many ways to which mineral deposits are formed, but one of the ways to have an insight is to understand, how mineral deposits are formed from primary sources. That is from hydrothermal fluid. We have different types of fluid. A fluid can be magmatic, it can be metamorphic, it can be sedimentary, and a number of sources. But one of the most important of all these sources is the metamorphic fluid. So I choose this topic so that I'm thinking, if we understand in and out of this topic, if we can understand in and out of the processes for metamorphism and understand the meaning of hydrothermal fluid and understand the meaning of mineralization, we can connect the two and then make a sense out of it. So let's start from the first word, that is, I actually compartmentalized the topic into three. We have three keywords: metamorphism, mineralization, and then hydrothermal fluid. So first and foremost, metamorphism. The word metamorphism comes from Greek word, from meta and then morph. Meta simply means change, and then morph simply stands for form. So literally, not professionally, literally metamorphism denotes, change in form of an entity. Anything that changes in form from one state to another, just like a child being given birth to, after 10 years, the child must have grown up. After 30 years, it turns to another thing. After 7 years, 70 years maybe, it turns to another thing. These are various stages of changes in form. So the same way our dear rocks also change in form gradually over time. So, but professionally, when we say metamorphism in geology, we're actually referring to mineralogical, textural, and to some extent, even structural changes solid rocks actually have to undergo when they are under different conditions of temperature and pressure, different from those under which they were formed. These conditions are possible when rocks are buried, because usually when rocks are formed, some of the rocks are formed at the surfaces, example, sedimentary rocks, and some of the rocks, of course, are formed at great depth, example, when you have plutonism. So when these rocks are buried at great depth, changes, variations in temperature, pressure conditions, different from one that forms them. So the individual minerals, because rocks are aggregate of minerals, so the individual minerals will have to gradually changes in order to adapt to the new environment. So for them to adapt, they will have to change. They change so that they modify themselves to be able to withstand the new environment. So when this happens, the mineralogy of the rock has changed. While the mineralogy is changing, the texture of the rock also gradually changes. This change in texture is what is referred to as fabric metamorphic structure. So that is how comes the structure also changes. It impacts a kind of, either mineral lineation or even foliations. So these are penetrative metamorphic structures. And then the mineral itself is converted from one mineral to another. For example, now maybe you have muscovites being converted to biotites being converted to another mineral, up to at higher grade where you have conversion into pyroxenes. So now, on the right side, I have, just an image to help us better understand this kind of processes. If you look at one of the boxes, you have sediments. Now, sediments can come from any other pre-existing rock after the nutritional processes. That is processes of weathering, erosion, transportation, deposition, and then after deposition in a basin, okay, known as sedimentary basin. After deposition and after geologic time, when we say geologic time, we are referring to, millions of years. These sediments are converted to form sedimentary rocks. The process of conversion of sediments into sedimentary rock is called diagenesis. And after diagenesis, those sediments are no more sediments. They are now sedimentary rock. Now the sedimentary rock, when this process continues when the parameters that were responsible for that diagenesis continue to operate, okay, the rock will now go beyond, will form sedimentary rock and gradually go beyond the formation of sedimentary rock. So in that aspect, you now the rock begins to experience the first stage of metamorphism. So that is to say that it was the same, sediments were deposited. These sediments were converted, to sedimentary rock. I said through what we said diagenesis, and then the same sedimentary rock, when those parameters continue to operate, goes beyond the formation of sedimentary rock to now begin to form what is referred to as metamorphic rocks. Now, this process, as easy as we can say it, it takes millions of years actually. And when sedimentary rocks, we all know, are more or less surface processes, but over time, when we say time, over geologic period of time, the sedimentary rocks gradually become buried. And as it becomes buried, we have geothermal gradient that is increase in temperature and pressure with depth. The deeper you go, the more elevated the temperature becomes. at an approximate of about 30 degrees Celsius per kilometer, and about 5 to 20 degrees Celsius increase per MA per million years. So you can imagine if a rock is buried at around 10 kilometers or at around 15 kilometers, what would have been, the temperature and pressure condition at that depth. Now, same process that forms your sedimentary rock begins to form the same sedimentary rock into metamorphic rock. When they continue to operate, the metamorphism will continue to be until when the rocks begins to partially melt. And when it begins to partially melt, it means metamorphism is about to end, because beyond metamorphism, you have melting, and the entirety of the rock, melts. And in this process, a new magma is generated, or lava, depending on whether it's going to be extrusive or intrusive. So in any case, you have melt that is generated when the same rock now goes beyond metamorphism. Now, when this magma is generated, gradually the magma crystallizes. Crystallization also takes geologic time. Sometime the rock can spend more than 50 million years, 100 million years before it completes its crystallization process. So the rocks, in any case, gradually crystallizes and a new igneous rock is formed. So any other type of rock can be formed from any other type of rock. But in any case, we are here because we want to see how, what happens within the window of metamorphism. That is when sedimentary rocks are formed before magma, before the rock entirely melts. What happens within that window? Thank you. Please, are we together?
Yes. Go on. I muted everyone. You're the only one talking.
You can move to the next slide. I have already few slides.
Okay, I should move to the next slide.
Yes, please. Thank you.
Okay.
Thank you. So, just like as I have said, we said a sedimentary basin.
No, you are not audible again. You are not audible again.
Okay.
I
said.
I can hear you now. You can hear you. Go on.
Okay. Thank you. So I said, just like as I have explained, a sedimentary basin is a container-like structure, just like a literal container that we know, that collects in sediments over time. It collects in sediments from various sources, whether from already existing igneous rock, or whether from already existing sedimentary rock, or from already existing metamorphic rock. But in any case, sediments are collected in a basin. Now, this basin can be continental setting, it can be ocean setting. So we have what is called ocean basin setting. So if we have an ocean basin settings, okay, the sediments that are collected are usually fine-grained sedimentary rock. And this type of sediments are called peletic type sediments. Peletic type sedimentary rock is formed from peletic sediments. Maybe, for example, now we can say, okay. So now what I have on this bus, I wish I can have a pointer and show some things. Okay. No, this is not what I'm looking for. I wish I can have pointer, but maybe we manage that way.
Okay. Let me see.
I'm just trying to see if I can locate the pointer somehow. And this is the basin I was talking about. Okay. So this is an example of a sedimentary rock that is formed from this. So now, yes, let me just delete this so that it doesn't confuse us.
Okay. Can you use this?
Okay, yes.
Are you
That is
seeing
what
the
I was
pointer
looking
I'm
for.
showing there? You can see it on your own laser pointer. You point to the laser pointer.
Okay.
Can you see it on your own? That's what I'm using here. If you can, but you're seeing the laser pointer I'm using.
Yeah, I can see your own, but how can I locate mine?
It should be below your own. But maybe because you're not the one projecting. I don't know if it's appearing because I'm the one projecting.
I'm not the one. You can just show. You can.
Okay. Yeah, this is where you are talking about. Yeah,
Yes, this is
polytic
what I'm talking
sedimentary
about.
rock. Mm.
Good. Thank you. That is what I'm talking about. So
Yeah.
this rock was formed from the basin I was, referring to, and then, as I said previously, when those driving factors for metamorphism, TT conditions continue to operate, when you pass the stage of diagenesis, sedimentary rock is formed, and the drivers continue to operate. I'm talking about, when I say drivers, I'm only referring to these three things: temperature, pressure, and then time. So when they continue to operate, this rock now goes beyond diagenesis. That means it goes beyond sedimentary rock. So it now begins to experience metamorphism. And the first instance, if we have a sedimentary rock, every sedimentary rock is porous, and those pore spaces contains, we don't want to say water, it contains fluid. Let's say it contains fluid. Okay. Now those pore spaces contains fluid. Now when these factors now, as they continue to operate, the pressure that the rock was experiencing, and of course the temperature, are enough to squeeze the rock, to squash the rock, so that the rock will have to, release the fluid it was carrying. When I say fluid, I'm referring to a number of things, please. I'm usually referring to volatiles, water, carbon dioxide, sulfur dioxide, methane, a number of things. I was referring to those things. And then referring to water component as literal water itself. But so the pressure that was causing these sediments, the pressure are divided into two. We have lithostatic pressure, we have deviatoric stress. Lithostatic, one that describes regional type of metamorphism. I believe all of us are geologists, so we can follow some of the terminologies. When I say lithostatic, I'm referring to. Okay, thank you. So the regional type, that one that produces things like, foliations, necessity, schistosity, and a number of things. When I say deviatoric, I'm actually referring to that form of stress that comes from tectonic activity, either compressional stress, either tensional stress, either shearing stress, or of course any other type of stress, but that one is directional. So when a rock is under this type of pressure, the rock is forced to have to release the fluid within it. Now, this is when I said one. Look at one in the box. In the box, I have one. So this is the first stage of fluid generation. Okay? Thank you very much. This point. So at this point, the type of fluid that you have are called formational waters. They are also referred to as basinal fluids because they are fluids that comes from the basin. So they are called either formational waters or basinal fluids. Why are these fluids important to us? It's because when you have ocean basin that collects in sediments, investigations have shown that some of the sediments within the ocean basin have salinity content even greater than the ocean waters itself. So the salinity is very high. And of course, the higher the salinity content, the higher the chlorinity of the fluid, of the sediment, okay, of the fluid that was generated. So when I said chlorinity, I'm actually referring to chloride ion. Please, are we together?
Mm-hmm.
Thank you. So I'm referring to chloride ion, okay? So this chloride ion is what mobilizes base metals. Base metals are metals that react, with an acid to produce salt and excess hydrogen, okay? This is just elementary chemistry. So the salinity content of the sediments, it led to the salinity content of the fluid released by this sediment. That is, I'm talking about the formational waters, the basinal fluids. And the higher the salinity content, the higher the chlorinity of the fluid. The higher the chlorinity of the fluid, the higher the mobilization for base metals. That means at the lower level of the metamorphism, at the onset of metamorphism, when you have fluid being squeezed out of these sediments, okay, this first generational fluid is where you have mobilizations for base metal type mineralizations. An example of this type of mineralizations are, copper deposits, zinc, lead, nickel, and the like. Some of the deep block transition metal.
Mm.
As metamorphinious, you step into the second stage, which is the amphibolite facie metamorphism. At the amphibolite facie, that is the medium grade metamorphism, you have what is called the volatilizations. The volatilizations, we are referring to removal of volatiles, okay? Removal of volatiles because we've been talking about sediments, peletic type sedimentary rocks, onset of metamorphism, green schist facie type, and the like. So of course, during the volatilizations, you have minerals that are volatile bearing minerals. Examples, your muscovites, your phlorophytes, all the classes of the micas. And then the amphiboles, some of the amphiboles, especially hornblende. Now, these volatile bearing minerals, as squeezing of the material continues to be, as temperature continues to rise, they are also squeezed to have to release the volatiles they are withholding. So therefore, as they release the volatiles, I have talked about environment. When environment changes, the minerals are converted to higher minerals, they upgrade themselves so that they can withstand the new TT condition. I have talked about that. So now, as volatiles are removed from the volatile bearing minerals, the grade of metamorphism increases. We call it prograde metamorphism. So, but these devolatilizations, okay, the volatiles that are released are the carbon dioxide, the sulfur dioxides, hydrogen sulfide, and other things. In any case, S is carried. Now, we need S in mineralization. Thank you so much for pointing it. Now, S, same way chlorine ion is the mobilizer for base metals. S is a mobilizer for all sulfide group of minerals. You can remember the chalcophiles, the pseudophiles, whatever. So S is a mobilizer for precious metals like your gold, your silver, and of course your platinum. So that means you expect gold enrichment around amphibolite facie grade. Why? Because at that have the volatilizations. What is the volatilizations? Removal of volatiles. What are these volatiles? I said compounds that carry the S, especially those that carries the S, like the hydrogen sulfide, sulfur dioxide, and other volatiles that we know. So these ones are mobilizers for precious metals. That is 2. And then 3. When we move upward now, we are assuming that these factors also continues to operate under prograde metamorphic conditions. Now the rocks now is into granulite facie. At granulite facie, you have partial melting. What is partial melting? Is a situation where the felsic components, the felsic minerals, your quartz, feldspars, and the like, these are called low temperature minerals in geology. Now, these low temperature minerals, they begin to melt as temperature rises, because the temperature at this stage is above 600 degrees Celsius, which is 600 is around the temperature of formation of quartz. It's around that. So now, at around that level, okay, the low temperature minerals will begin to melt, because when you have a rock, remember the Bowen's reaction series, the left arm are the darker minerals, and the right arm, are the calcium, sodium, K, potassium, up down to quartz. Now, these ones are usually low temperature. So if you have low and high temperature rock, and you are now revising the process, you want to melt the rock. If you are melting a rock, okay, the first mineral that will go into melt will be the quartz. While if you are crystallizing a rock, the first mineral that will crystallize will be the olivines, down to pyroxenes, down to amphiboles, down to this, and downward. So now in partial melting is a situation where the low temperature minerals within a rock begins to melt. So you have two systems in one body. You have two phases, okay? One phase is melt, the other phase is a solid component. Now, the solid components do not melt. Why? Because their temperature, their melting point is not reached. But they cannot withstand the new temperature environment, so they readjust themselves. Because they are readjusted, their form will have to change. When their form is changed, that means they are metamorphosed. So these ones are metamorphic rock. And the other phase, which is the melt phase, it has become a melt. Same way you are looking at magma. So this one that has become a melt will recrystallize, and the recrystallization pattern will respect Bowen's reaction series. So as it respects that, the higher the melting point, the higher the crystallization is. So this one also crystallizes. So both the two recrystallized. So that means in one system, you have a component that is a metamorphic rock, and you have a component that is an igneous rock. That is what brings a mixed rock. And that is the meaning of metamorphization. So in metamorphization, you have all the darker minerals are actually metamorphic rocks, and all the lighter minerals are actually what? Igneous rocks. If you have igneous and metamorphic rock in one body of rock, the rock is called a migmatite. Now, how does this now relate to mineralization? If you have the component that completely melted, that is the lighter minerals, when they melt, the chemistry is divided into two. You have compatible elements and you have incompatible elements. Now, compatible elements are elements that are compatible with the solid phase, while incompatible elements are elements that are only compatible with the melt phase, but incompatible with the solid phase. Please, are we gradually following?
Yes, we can hear you. Yeah.
Thank you so much. So,
Okay.
as this crystallizes now, the last residue of the fluid is referred to as magmatic fluid. And in this particular case, okay, it's actually metamorphic. Why? Because we took its genesis right from our progress metamorphism. So, but this particular stage is actually what? Magmatic fluid. So the last residue of the fluid is actually water, because magmas, no matter how pure, they contain water. So, but this water, the incompatible elements that you have, let's say, for example, now some of the, rare earth elements, the rare earth elements have large ions, so they are not compatible with the solid phase. So during melting or crystallization, they choose to be with the melt. So as the rock continues to crystallizes, to form a rock, this large chunk or bundle of materials, okay, they are concentrated within the fluid. Because what? Because they are incompatible with the solid phase. Why are they incompatible with the solid phase? Because of their ionic radii, because of their size, charge of the ions. This one is a long story. So, but they are incompatible. Because they are incompatible, they are concentrated, with that last fluid, which I refer to as, magmatic fluid. So this now, after crystallization, recrystallization of everything, this large chunk, okay, crystallizes as a mineral deposit on its own. I just give an example of the rare earth elements, and of course some of the precious stones, even some of the precious metals. In any case, from all the three stages, from fluid that comes from formational waters or basinal fluids, that is stage 1. Stage 2, fluid that comes from devolatilizations or removal of volatiles, as program metamorphism continue to be. And stage 3, fluid that comes from partial melting or magmatization process, okay, which I talk about compatible and incompatible elements, the last residue of the fluid, water, whatever, this crystallized. In any case, a mineral deposit that is to be formed is dependent on the dissolved lot present within the fluid during melting or crystallization. What do I mean by this? Let's take the last stage, the last stage, the incompatible stuff. If during the partial melting, you have the darker minerals that are metamorphosed that have had to readjust because the condition wasn't favorable for them. Okay, most of the metals and ions complexes within them are extracted, and then from where the fluid also took its source, there are other metals, ions, and complexes that are also extracted. Now, this will determine the kind of or the type of dissolved lot within the fluid. If it happens because of the genesis or because of the parental hood, okay?
Sorry, the audio seems to be lower now.
Okay.
Okay,
If because of Thank you. If because of the parental hood of the rock or the fluid, the dissolved lot happens to have, gold complexes and ions, then of course the mineral deposit that will be formed is going to be gold. Then if it is mobilized by the S, then you know at what particular metamorphic grade it is, okay? And if it happens to be at the lowest grade, that is the box where I showed one, formational waters and this, when we say base metals, this is a family name. So what metal is to be formed or what deposit is to be formed is dependent on the enrichment of the dissolved lot, particular elements or group of elements within this fluid. What determines what is present has to do with the source. Has to do with the source of the sediment. The source of the sediment has to do with provenance. It's a cycle. Okay, it's a cycle. Can we please move to the next slide? Please, are we together?
Yes. That's good.
Okay, thank you. Here, this is the last slide. Okay, this is the last slide. I only brought this to show an example, just an example, maybe just one example with our own case in Nigeria. In Nigeria, we can say that the entire western half of this country, we have prominent schist belts. So this schist belt took their provenance from the examples we've been talking about, because the schist belt are actually divided into two. Some of them are Kibaran, some of them are Pan-African, according to literatures. But whichever one we have took, prior to Pan-African origin, the entirety of the position of Nigeria, where Nigeria is today, was actually an ocean. So therefore, sediments were gradually deposited in an ocean basin setting, just like I have explained. Okay. Now, as sediments continue to accumulate, the oceanic crust is very thin and is fragile. So it began to sink. As it sinks, it draws the already stabilized West African Craton and the Congo Craton closer. So you have a compressional event. So as this comes forward, you have some of the sediments, were melted, and a large chunk of plutons were formed during Pan-African orogeny, and some were actually metamorphosed, and that is our schist belt now. That is the schist belt. I'm just trying to summarize a very long stories of so many things. Please pardon me for that because of time.
Yep.
So now, when we have the schist belt now, you can exactly put the schist belt in the context of what we have talked about. Initially, you have pelitic type sediments. These sediments can be sourced from any other type of already existing rock, whether sedimentary rock, whether igneous rock, and of course, whether maybe metamorphic rock. So now you have the sediments are metamorphosed, sediments, and metavolcanics. That is, anyway, let me not even go into that. So as program metamorphism continue to be, okay, because of the provenance of the sediments, you have some dissolved lodes and of course ions. Wherever you have meta sediments, wherever you have meta sediments, not only in Nigeria, in the entirety of the world, the meta sediments have higher ground value for gold compared to any other group of rocks. It is because of their, origin, because of their setting, because of where they took their genesis from. So if you go to the schist belt in Nigeria today, is an area that is known for gold mineralization. Okay, and of course, it is also known for some of the base metals type mineralization. It's because of this prograde stuff, metamorphism. The same context I have explained before. So if one is looking for gold in Nigeria, even though there are lots and lots of things that need to be said when gold is mentioned, because it's not only lithology as far as Nigeria is concerned. It's not only lithology that controls gold. Beyond the schist belt, we have other areas of gold mineralizations. Okay, beyond lithology, you have transcurrent, transform fault lines that actually served as conduits and passageways for fluid. That also controls gold. We also have, ancient river channels that also contains gold. And of course, the little controlled by the lithology is found within the western half of this country around the schist belt of Nigeria. And then the examples of where we talk about, the magmatic fluid, the compatible and incompatible elements and what have you. We also have mineralizations in other parts of the country that were actually sourced from that, even though those ones do not take source from metamorphism. But we have examples around, especially around the younger granites of Nigeria. And a number of things. Let me just conclude. Maybe during questions and answers, we get to shed more light on many other things.
Yep.
Thank you so much for your time, and I thank everyone for the opportunity, especially Dr. Gideon. And let me not even forget to wish you a happy birthday. I have seen it on the platform. Thank you so much.
Okay. That's very interesting. I was telling you, this kind of topic, is highly, okay, let me put it, it's a bit technical.
Okay.
And it's very okay that most of us that are actually coming up understand the root of certain things. Here, not only technical people that are here, we also have some business people that join us that actually want to understand how minerals are actually formed, how they can trade minerals. So because we are also into the business of bridging the gap between the technicalities and the business aspect of it. Some people are here, all the things they're saying, they want you to tell them how to make money or how to find minerals. Understand? But I understand that, which is very okay. You took me back like somebody like me. Most of them I struggled to. That's why when I even did my PhD, I was having issues with industrial reporting kind of way and talking and academic way of talking. You understand? So this shows you are trying to bring us back to the roots. Now, for the benefits of a lot of people that are here, in all the things Doctor has been saying, I'll tell you what he's saying in a very simple word, so you don't get confused. And even if you don't understand what he's saying, what is he trying to say? He's trying to tell you that there is something that gives rise to something that gives rise to something for us to get minerals. That is what he's trying to say. And what is that? He's trying to tell us that metamorphism is the agent of fluid production. Fluid, when you say, because every mineral recrystallizes, comes out from something, somewhere. Something happened before those minerals come out. So what we're trying to say here is that metamorphism gives rise to fluid, and this fluid, based on the temperature, pressure conditions at different phases, they recrystallize and give different forms of minerals. And these fluids are actually carried from one location to the other because of structures So we should understand that, which plays a very major role, because whatever that is produced, it's just like for us to say there is a reservoir rock and a source rock. Now, if you have a source rock and whatever you've produced there, and there is no condition to transfer them, the reservoir rock will not have anything to give you. So structures is like a conduit for fluid movement. So at the end of the day, all these fluid have to migrate through structure. So that's why you need to understand that if you are looking for gold, for example, and this thing that actually happened, what do? You start looking for structures, because in the field, because I will come into, my contribution will actually be in terms of field, basically field observation. Because if you are talking about this, you need to relate it. Okay, how can you, possibly see this in the field? For example, if you are talking about alteration zones, veinings, or mineral assemblages, for example, the sericides, these are the things you can see in the field. I'm only trying to tell you to understand that this thing has happened down there. You understand? When you see alteration zones, you see the veinings, you see the mineral assemblages like the sericide, the chloride, the quartz and the pyrite that often reflect a kind of retrograde metamorphism that leads to hydrothermal reactivation. These things is something you can see in the field. You understand? So the pathway is very important, which is the fault, the joints, the foliation planes. These are all structural controls that link metamorphism to mineralization. So all we are trying to say here is that metamorphism is very important for you to say, mineral is going to form. You understand? So that is just it. And I would also want to possibly maybe a kind of ask Doctor a few questions. Maybe it may just throw more light on that. So possibly then we can now give audience to some other people on the platform. Maybe that, will also necessitate that for them to understand much on what we are actually talking about today. So I think one of the things I wanted to say, I've actually mentioned it. I wanted us to throw more light on how the metamorphic fluids, evolve into hydrothermal system that is actually capable of transporting these metals, which I think is actually what I've said a bit, but I also wanted possibly to throw more light on it. And also the importance of, signatures, the signatures that we can actually see in the field and observe to say, it seems something has actually happened here. Because most of the time when we see some of these things, the issue we have, and most students have, and young ones have, is that when you go to the field, they'll be asking you, they want to see what you are talking as in, verbatim. It's not, it's not verbatim. Some will ask you, how do you know there's a structure here? How do you recognize it? Because it's what it is. How do you know there's a structure? How do you know that the metamorphism has actually happened? There was some of the video that I did, somebody was asking, a lot of people will throw in certain questions. And the video I did last time, I went to somewhere in Nasarawa, just about last week. So I was trying to explain what happened, that seeing this rock, I wasn't there, but there's some evidences that have shown me that there's a fluid that have passed through here. And there's an evidence that has shown me that there is a high temperature along this zone. You understand? So what am I trying to say? We need to be able to identify these things in the field. So that is just the area I actually wanted you to actually put more light on. Then then we can now give opportunity to some people. If you want some questions or you have some contribution, just raise up your hand. I will just call you up while he just try to throw more light on this.
So am I to talk?
Yes. I think you can say anything. You can say something now. Why some people might want to say something.
Okay. When you said how do we now relate what we have said to to the field? You see, maybe some of these things, maybe some of the
let me just say it this way. for the benefit of a lot of people here, because I know what they'll be saying is, how do we see it? How do we know? What signatures can tell us, okay, in the field, this is metamorphism that actually happened here. This is actually, what structures, help one can actually observe this in the field.
I will give us very simple instances.
Yeah, okay.
Anytime any one of us is in the field, anywhere you see foliations,
yes,
anywhere you see foliations, then quote me anywhere you are in metamorphic environment. Metamorphism must have taken place. Anywhere you see mineral lineation. Now the question is, how do we identify foliation and how do we identify mineral lineations? Okay, that is maybe some of these things we need to show them. Because we can have another class for this, but let me just say something brief. Okay, when we are in the field, and then we know how maybe biotites should appear within a rock, and then we know how quartz should appear, and then we now notice that the quartz, the biotites, and some of the feldspars seems to be oriented in the same direction. Maybe along north-south direction, that is vertically, or maybe along east-west direction, that is horizontally. Then, of course, the direction to which they orient themselves is perpendicular to the direction of the force that causes the new orientation. Okay, and once they are disoriented or they are oriented, that means metamorphism must have taken place.
Exactly.
Because this is what I was referring to as when I said fabric metamorphic structures. So anywhere you see fabric metamorphic structures, metamorphism must have taken place.
Exactly.
Now, what type of metamorphism is dependent on the mineral within the metamorphic rock? And then, as you rightly said, what we should be looking out to are actually the fractures, the dikes, the veins. Because if we are in maybe migmatite, an environment that, the last stage I was referring to when I mentioned partial melting, I mentioned migmatization and a number of things. If we are in such environments, what you look out to will be, the felsic components of the rock. Because it's the felsic part that actually recrystallizes. Okay, recrystallizes the melt. And when I talk about the incompatible elements, it has to be within the part that melted. So you target those areas. Because of course the darker portion, is the metamorphic part, but it has been extracted. All the major components must have been extracted out. And because of the, the chemistry of the ions that were extracted, they may not be within the metamorphic part. They will have to be within the felsic part. So one target, especially quartz veins and pegmatite lots and veins and dikes. One targets such things. Exactly. If one is in this vein, primary gold is usually been reported within the quartz veins.
Yeah.
Okay. Yes. Within the quartz veins, we call them gold-bearing quartz veins.
Yes.
GBQV. That is what we refer to them as. Exactly. So, and what we have done is useful in the sense that if one is into exploration, there are areas you don't actually target it. For example, now, if one is given a task to have to look for gold, in Plateau State, Plateau State is not in anywhere related to the schist belt. So, how will you begin to target? You understand what I'm referring to? Yeah. How will one now begin to target that? Because you have younger granites, which are even Jurassic, are very young, Mesozoic granitoids, and brought about by, ring faulting, cauldron subsidence, and what have you. There is no direct relationship. So if one is looking, if one will have to, by all means, look for gold within such areas where you have younger granites, then that means his focus will be that to start from geophysics. That is to be able to locate those regional transform Pan-African fault systems I earlier talked about. Because this must have passed maybe through an area, and those fault systems serves as conduits for passage of mineral fluids, and of course, because they have radiant faults. It's a big story as well. There are radiant faults that dominate from the bigger one. So gold nuggets might have deposited along those lines. So if one is into exploration, one can actually look at the environment where he is. One cannot go to, another example, one cannot go to Mambila Plateau and then begin to talk about maybe simply begin to talk about base metal types of mineralizations, because what we have done today, we have done a lot to show that you expect certain things in certain areas. Only that for time factor, we have so much restrictions. Maybe as time goes, I believe as time goes, we get to shed more light on some of the things. And because we have this class, anytime we'll be having another class, will be a kind of building up. We have already set a foundation. So when we are coming to now talk about maybe a class on indicators, only field indicators as to this class, then this will have been an extension of our next class. And it will have been very easy for some of us to easily, nail on some of these things.
Okay, Doctor, thank you. I think you've done very well on exposing the root of mineral formations, from its really early and critical stage, which most of us do not really understand how these things come. Because I would say that there are things that I normally tell people when I want to explain about metamorphic rocks. I said, when I go to any location, I've made several videos on that. Just like what you're saying, how do you recognize foliation and all that? If anybody is following most of our videos recently and submission, because what we've tried to do these days is to try to explain geology with videos. Whatever you understand, because geology is all about observation and seeing, because most of the things we need to recognize, we will not see it if you go to the field, definitely. I could remember that somebody I posted a barite as much common as that mineral is. Till now, there's been a lot of argument that it is not barite. You understand that it is not barite, that it's calcite. A lot of people from the extent, So I think there's much more we need to do in terms of trying to, I think, maybe Abigail or Chisholm, if you have any of my link and all that, like what he said, especially on the foliation, on the biotite, the rock foliations and all that, we've mentioned all those kind of things before on with the video, for you to actually easily observe and see some of these signatures that he's talking about. So that you wouldn't say, how do I know that this has happened here? Rock alone. I tell people that if you see any rock that doesn't want problems, what are the rocks that do not want problems? These are the rocks that are the way they lie horizontally. There is no disturbance, no foliation. The grains are intact the way they were formed. Quartz grains, no deformational activities, and so many other things and all that. You find out that those kind of rocks, those kind of rocks are not actually fractured as much as what you can see in the metamorphic rocks. Now, metamorphic rocks has been fractured, had a lot of deformation, even along the lineations at the weak points where things can actually migrate. In short, when you are dealing with metamorphic rock, most of the foliation planes are the location that you can easily pick some signatures that can tell you something about that location in most cases. But in some other rocks, like if you go to shale now, for example, if you go to the lower Benue Trough, maybe Abakaliki area, and you see most of the shale. There are some ones that you find out that you see the foldings, you see the faultings, you see a lot of activities on the shell. That will tell you that this shell has undergone several deformational processes, which can give rise to fluid mobilization and mobilization within the same, formation. So it is an idea that something has actually moved through this particular region. But if you see most of the shell that I've seen that are lying clean, nothing has happened, you see them after this, you see the other one after that, you see sometimes you don't see even quartz veinings along it. But the quartz veinings are mostly seen on most of the shell that have been turned or moved or slopy and all that. So I think we'll have 3 hands up at this point. Let's first of all, Austin, please, can you make your contribution or your question? You can talk right now. Austin,
okay,
you can.
Good morning.
Okay.
Good afternoon. Good afternoon. Can you hear me?
Yes, we can.
Okay, Thank you so much, Dr. Omar. I enjoyed your lecture. It was really thought-provoking. My name is Austin Okonkwo. I'm from Enugu State. Yeah, I want to ask a simple question. And because I'm a field man, I go to the field a lot. Are all metamorphic environments mineralized? Because why I ask this question is, you talked about the schist belt in the western side, that's the southwest, which are basically based on, you have the basal rocks there as a metamorphic basement. But when you come to the southeast, maybe around Calabar area, you know, where you also have some metamorphic basement, you find that that area is not as highly mineralized as you have in the southwest. So what could be the reason? That's why I asked that question. Are all metamorphic basements mineralized? Do you have all of them mineralized? Thank you.
Thank you. So, thank you for your question, Mr. Austin. It's not possible to say that all metamorphic rocks are mineralized. It's not possible because, after all, the entire meaning of mineralization refers to an anomaly, a situation where you have abnormal concentration of a particular metal or group of metals in a particular region. Okay, so it's not possible. Had it been we can have all metamorphic rocks mineralized, then the definition of mineralization wouldn't have been what we have said today. So, but what are we saying? You know, metamorphic rocks are not restricted to the schist belt. Even in central Nigeria, where you have much of Pan-African granitoids, okay, 60% of the plutonic rocks, okay, at least have been migmatized. The way basement rocks undergoes metamorphism is not similar to the way sedimentary rocks undergo metamorphism. For sedimentary rocks will respect all the stages of metamorphism, okay, beginning from green schist facies, then prograde to amphibolite, then move to granulite facies, which is the highest grade. But if you have basement rocks, that is, for example, now the Pan-African granitoids that we have in Nigeria, all over, you can see them around, okay, around central and eastern part of this country. Most of these rocks have been magmatized. If igneous rocks or basement or crystalline rocks are coming to be metamorphosed, they don't respect the stages of metamorphism. Why? Because the temperature and pressure conditions that is enough to begin to cause metamorphism for sedimentary rocks, okay, won't change anything for basement rocks. Why? Because their condition at which they were formed is already higher than that in condition. Because metamorphism is when the rocks, we can say the minerals, have been subjected to PT conditions different from what they were formed from. So, but igneous rocks were formed from igneous comes from the word fire. So they come from higher conditions, higher PT conditions. So low PT condition won't change anything. So they begin to metamorphose at around upper amphibolite region. Okay, then the next thing, they enter into granulate facies and they become migmatized. So you have migmatizations. I can say that 80% of the Pan-African granitoids we have in Nigeria today are actually migmatites. And we cannot say that all this group of migmatites are mineralized. It's not possible, because what brings about mineralization, as I kept saying, I also say it today during my discussion, that dissolved lots within the fluid that was generated is what ultimately determines what mineral is to form, where and how. So if, the mobilization for the dissolved lot is low, or maybe the parental hood itself does not carry these ions and complexes, okay, then of course you may not necessarily expect mineralization. I don't know if I have answered your question.
I think you've done very well there. Let me also add to this Because what is certain is typically the first thing is that no, metamorphism is not equal to mineralization, in the sense that we are talking about like what you've just explained, which is recrystallization of or transformation of an existing rock in terms of the structures and the mineral they have. Do you understand? So this process is like a mineral composition and texture that is already there. It does not automatically introduce all forming elements or mineral during metamorphism. So metamorphism gives rise to minerals when they are, the fluid is actually enriched in metals. Like during, like you explained about the volatilizations or metamorphic fluid, when they are now moving along the path, or when they move along the permeable structures, or when they move along a track that is reactive. That's why we are talking about scan. When we have carbonate rocks that are very reactive or some sulfide reactions, you now find out new minerals forming along that process. So that's why we are very, very much interested in carbonate rocks. Once the rock has Ca more, we'll rush for it, for sulfides. This thing I'm telling you now is much in some of the lead zinc locations. That I can see in the lower Benue Trough part of, if you're going towards Benue, Kiana area, you find out that some of the carbonate rocks actually are associated with some of the lead zinc mineralization in that area. Why? It's because possibly the metamorphism must have passed through a reactive zones, which introduce some of these all forming elements like the lead, like the zinc, the copper, and the gold. And that's why if you definitely test those areas, number one thing you see is that you find out that silver is higher. You must see gold part of it also. So it's not just, it's along the path when you have all those conditions that are necessary for that mineral to form, that those things can actually form. I think, I don't know, Austin, I think we've tried to at least answer the ones we can on that aspect, right? Okay, Dr. Mrs. Alao, please, can you make your contribution? Okay, you can talk now. Madam Salau, you can talk now. Okay, if you can, Mohammed Lawal, can you?
Yes, I can.
Okay, go ahead.
Good afternoon, Mr. Gideon and Dr. Omar. Thank you for this wonderful presentation.
Thank you.
I just have one question.
Okay.
Let's say as a layman, like as a geologist, not experienced geologist, I went to a field and I want to like kind of explore for gold. Like, what are the steps that I'm going to take in the field to discover and also
Doctor,
including
that question carries plenty children. Okay, go on.
yes, like are there some kind of rock that you can see that you automatically it tells you like there is gold here or something like that?
What do you have to say before maybe I have anything to add to? He said he wants to go to the field as a layman. What will tell him? You see what I'm telling you? You see what I'm telling you? Most people that are here, what they want is, how do I know that this mineral are here? So that they'll just take it and make money and go.
The issue is there are lots of misconceptions. Let me use the opportunity to talk about one. People are now into buying what they call gold detectors.
Yes.
And people from owners will just buy one, go to the field, and they call themselves mineral explorationists, and they usually go and explore for gold.
It's killing a lot of people right now.
Big misconception. There is nothing in the world that is called gold detector and gold, and it will just detect gold. Not that way.
Check your audio.
Yes, but because the question that is just asked now, for one to locate gold, literally, or as a layman, let me just be afraid to say that it's not possible. Because there are certain things you need to know, there are certain things you need to acquaint yourself with. But in any case, let us say, okay, as a beginner, as a geologist, for you to locate gold, first and foremost, you need to look for environment of the gold. That is why I kept saying you cannot go to certain environments and just think of locating gold, that gold can just be found anywhere. No. So
Your audio, we can't hear you, sir. We can't hear you. Okay.
Okay, I said one, you need to look for the environment for the gold.
Yes.
And then two, one needs to start from regional surveys. That is using some components of geophysics. Okay? That is to detect some lineaments. Those components of geophysics are not done to detect the gold, but to detect lineaments that might bifurcate and radiate to be able to lead to where gold can be found. Then third, you now go into the field and start your reconnaissance. It's dependent on whether you are looking for primary gold or secondary gold, that is placer. If you are looking for placer, you don't need the two things I have mentioned above. You need to follow the stream channels and look for, that is what sedimentologists refer to as oxbow.
Yes.
An area where a stream, either curved or bifurcates into 2 or 3. Okay, so those areas, one targets those things. And if one is looking for primary gold, let me just say that to look for primary gold, you need to look for 2 major indicators. One, look for the quartz veins. Target all the quartz veins. That is one. 2, target sulfide minerals. Virtually all sulfide minerals are gold indicators. Example now, if you are in the field and you are able to target pyrites or chalcopyrites or arsenopyrites, okay? All the family of the minerals that ends with S, let me say that if you can target those ones are already pathfinder minerals for the gold. There are also pathfinder elements for gold. One needs to go into geochemistry, into SEM, into a number of things. So as a layman, I cannot say that it's possible to go to the field and detect gold. Let me.
I think his question, like you've actually done justice to the two, both as a technical man and as a layman. Like what you just said, as a layman, like what he's saying, first of all, is where are people mining gold? Because you don't want to use a technical information. Just like for you to tell some of these guys, go and look for linear and go for remote sensing. No, what they do is that I could remember when I did some work in Kaduna, we left there. After a month, we got back there. The guy that followed us to sample and do some work had actually invited over 1,000 persons to occupy the locations. Do you understand? Now, as a layman, first thing is, are people mining gold there? Are there any history of mining around there or gold around there? If there is, what do you do next is you go and carry your pan, take your pan, and start taking sands and start washing. That does not involve any geophysics. It doesn't involve any detecting. It doesn't involve, you understand? This is as a layman. I'm not trying to teach you remote sensing now or teach you geology. This is what anybody can do. You sure most people that have made money in gold are not even geologists. They are not even technical people. Some of them, what they do is that they leverage on the information technical people provide over the years or the history. They go into it and they now start doing it. All the places I've visited, I've seen some artisanal guys. What you see them is that they use their detectors and the only detecting machine I've seen that work much for them, even in Ghana and everywhere, is see those machines that are detecting, the ones that detect nuggets, that detect coarse grains gold. But most of those machines that based on signal and wavelength and frequency, most people do not understand the geophysics behind it. Frequently, they will call me and tell me, Gideon, do you have any gold detecting machine? Do you have this gold? I don't know what to tell them. I get confused. I tell them, no, it's a gold detecting machine, but there is actually what we look for. It's just like a first face. Do you understand? Somebody will say, every woman you see on the road, how do you know who is okay, it's just like somebody will come and ask me and say that, is the woman barren or fruitful? I said, no, I cannot answer that question. But the first thing is that I know that she's a woman, she's a lady, and this is a man. Do you understand? Every geologist should be able to go to the field and they understand that. Somebody was telling me, I did all these things you are saying, but I did not see mineral. I said, no, I am training geologists to understand the basic thing to know that this is it. I'm not telling you to find out if this woman can give birth or not. I am only telling you to understand that this is a woman and this is a man. At least you should be able to now say, let me now focus on the woman, to now start saying, let me bring other doctors to come and find out if this woman will be able to give birth or not. But if you're a geologist, you can't detect who is a woman and who is a man. How do you start from? You understand? So this is what I think we are trying to, the basic thing we are trying to do. It doesn't mean that you just, everything will tell you, go to the field, it works. After all, there are a lot of things you might have done and it wouldn't work that way. Okay, I think, Mohammed, let's give specs to Ibuko Nolowa. Okay, please, can you make your contribution? You can talk now. Are you there? You can unmute yourself. You can unmute yourself.
Okay, good afternoon. Good afternoon, everyone.
Okay.
Can you hear me, sir?
Yeah, we can hear you.
All right. Thank you so much, Dr. Omar, for this session. While he was talking, I was just remembering those things I did in geology. Okay, what I wanted to say is a contribution, not a question per se. Yeah.
Okay,
so
thank you.
The thing is understanding what really matters. If you're able to understand all of these, and then it will be sweeter in the field when you begin to see what you have learned in school. You know, it took us from igneous to sedimentology to metamorphism to metamorphization, all of this. And then when he was talking, I just remembered those things right from the uni, and it made so much sense because we learned all of these things in isolation. We have a particular course known as metamorphism, igneous geology. It's like this is something I used to say in school back then. I used to say that geology is sweet, and then when I was talking, I was like, he's bringing out the sweetness in geology. But the thing is, understanding is what matters. If you are trying to look for, okay, what should I look out for? What should I take note of when I go to the field? You might not really get it because what you are looking out for might also be the same attributes for something else. If you really understand the basics, it actually goes a long way. Thank you so much, sir. I really love your presentation, and I would like to advise those that are still in school, the undergraduate, that try to understand what you're learning. Don't cram it. Understand. If you need resources, go on YouTube. Try to imagine those things, and then the beauty will come out then when you're on the field, and then you really appreciate it.
Yeah, exactly. That's what I emphasize on. I emphasize on people. If you're a geologist, you've not found yourself in the field, you can learn faster by seeing it, observing it, watching the videos. It helped me a lot and all that. Being in the field, whatever I see in the video, if I go to the field, I try to see it, take a picture of it, take a video of it, try to tell other ones, what do you think of this? What are you saying? Before 2 or 3 persons say the same thing, you know, that is already registered. There is no way I will see that when you see certain rock, you talk about it immediately. Somebody will tell you, have I done petrography? Have I done this? I said, no, it's a 20 years of being in the field. I say, as a geologist, you should be able to see a rock and start thinking certain directions. Before you go to petrography, you understand? Before you go to that, you don't go to the field with microscope. You don't go there with slides. You don't go there with how many people can afford XRF? Each good XRF today is not less than $100,000. You can't have many. Where are they? Do we have it in any university? I'm not sure any university has that. No university in Nigeria has that. Do you understand? So these are the things. So you need to understand that you, as a geologist, you should have something you are suspecting and the reasons why you are suspecting it. this is this because it's behaving like this, it's behaving like this, behaving like that. Then at the end of the day, you want a detailed study. You can now start going to your, it's not every rock you collect that I finally end up in the lab. But there are some rocks that you see immediately based on what I'm looking for. There are some rocks I'm looking for. Once I see them, I don't need to go anywhere to tell you there's gold here. No matter what you do, I'll tell you there's gold there. Go there, you dig there, you see gold. You understand? So I think, I'm also thinking, okay, Dr. Madam Salau, you can talk now. Madam is an authority in the gold region of Ankashis Belt.
Thank you very much, everybody, especially the presenter. You've done a good job. You did it well. But when we talk of metamorphism, do we relate metamorphism to igneous too? In why we're sourcing for minerals? Where do we have the, because anything you want to do today, as I've been saying, is related to structure. If it is not in place, and you have to go through the Precambrian section where metamorphic rocks are present, you must do your structural study very well. Otherwise, it will be as if to say you are looking for coal in the younger granite, just as you have said. And you see, this structure is becoming of paramount importance in exploration. You know why? Nobody have done it. To bring structures, map your structures, map your joints, map your everything you see, foliation and whatever in the field while you are doing this. By the time you plot it, it will give you story. The story is what we are now using to do what? To further explore for our green mineral of today. The gold, the metal, and the rest of it. Please, let's try to start doing that. When you are in the field, map any joints, map any fracture, map any of those structures, the fold, the fault, because the fractures combine the joint and the fault. It all depends on the displacement. If you can do that, then some of us can just go to the field and say, oh yeah, start digging, because it will be a precise point for you to look at. It's not every joint, it's not every fault that are linked with mineralization. It's not. We have not been able to find that out in Nigerian exploration. The moment we can do that, we have to go. All you have said, it's well with mineral explorationists. I've made the comment on the platform. You do well, Dr. Umar. We need to see more of you on this platform, and you need to carry us along. Thank you very much.
Okay, thank you
so much. And
from the platform, thank you, madam, thank you. Some Hashim Yusuf say, thank you so much, sir. This is invaluable. I'm so proud of this. He said he's very, very proud of you for this wonderful presentation. Also, we have on the platform to someone else also who is here. Okay, this one doesn't have a name. It's like Xiaomi or something. I say thank you for this wonderful presentation interaction. Can we have access to the recording of this presentation? Yes, you can have access to that at the end of the day. Dr. Ms. Salah was an insightful presentation and very educative, also very relevant to entrepreneurship mentoring in mineral exploration for geoscientists. Well done, Doctor. Thank you so much. That is coming from Abraham Yaradua Akali. He said, Dr. Umar, this class is really enlightening. Well, God bless you, sir. From much appreciated from David Ndungu. And so much from others. So please, if you have any question, you can also throw it there. Even after this, we can also answer your questions. Our platform is always ready there. Okay, we're still having a lot of hands coming up. I will give opportunity to Ali. Ali, can you make your contribution or you ask your question?
Hello, can you hear me?
Yeah, we can hear you.
Yeah.
Thank you very much, Dr. Umar, for your wonderful presentation, even though I joined the presentation very late.
Yeah.
But someone asked a question as regards to how you can explore for gold. And I think the presenter stated something as regards to regional survey, where he made mention generating lineaments and all that. So my first question, I just want to ask, when it comes to lineament generation, that's of course for structures, how reliable are the methods for generating lineaments, specifically the use of aeromag or use of satellite imagery like Landsat, ASTAR, digital elevation model, among all that? The reason why I'm asking this is because sometimes in the past, I was able to, I generated some of these lineaments and I went to the field, and funny enough, I could not even find a single fracture. Rather, what I was seeing were just buildings and what have you. Well, that was my first question. Secondly, with respect to gold exploration, we seem to have been so focused on gold related to structures, looking out for veins and what have you. But then, what can we also see as regards to gold that is lithologically controlled? In this case, no longer structure, but within the rock itself, you find gold here. Even here in Nigeria, some migmatites and gneisses and what have you, we find gold within them. So what can you really say as regards to that? Thank you very much.
Thank you so much.
Okay.
How precise?
Okay.
How precise the use of aeromag is? Yes.
Okay. I'm saying that your audio.
Okay. Can you hear me now?
Yes.
Okay. When you ask about how precise the use of aeromag images is, I like this question because this is one of the very big difference between textbook geology and field geologists. If you are into textbooks and other things, you will be seeing aeromag, do this, extract this. I'm telling you, if you are into the field components, you will know that the use of this aeromag to detect lineaments is actually vague. It's actually vague. Because, I mean, some of the images you get from wherever you buy some at this and that, you use your softwares to this. In fact, some of these things will instead, direct you to an opposite location where it's not even entirely possible to even get what you are looking for. But maybe I will suggest, okay, my suggestion is that one should rather resort to the use of, remote sensing Landsat images. And then that is, using those ones is dependent on how versatile the person is, in softwares like ArcGIS, to be able to extract those images with precision and then use them. And how are they important as far as gold is concerned? Because in Nigeria, we are able to relate primary gold mineralization in Nigeria to be related with those regional transcurrent fault structures. And once you can detect those ones, it's not as if directly when you can detect those regional fault lines that you are in business. No, it is that while you have a regional fracture coming up, you usually have, radiations that also emanate from the regional structure. In most cases, they are at perpendicular direction to the direction of the regional fault. The regional fault in Nigeria is is defined to be northeast-southwest. So in most cases, while mapping, when you find structures that are usually oriented along northwest southeast direction in most cases, and these are probably radiant faults that emanated from those ones. And they've been proved to, in some locations, to be related to primary gold mineralization, especially within the schist belts. And I cannot, what was the second question? I cannot.
I think it's on, yeah, I think he's talking about how lithology can also control the gold mineralization. Lithology, apart from.
Lithology, as far as I know, lithology only control gold when you are in situations where lithology truly controls. That is within the schist belt in Nigeria. Outside the schist belt is not, in fact, even within the schist belt, it's not only lithology that controls gold, but lithology is a very good contributing factor. Beyond the schist belt, it's not lithology that controls gold, it's actually structures. That is, in all this, we're actually referring to primary gold. We are not referring to secondary gold. Because for secondary gold, they are also divided into compartments. As I said earlier when I was making my presentations, you have ancient river channels that are proven to host gold in Nigeria. I have personally mapped some areas around Abuja, and today they are on it. They are taking it. So, and I have seen, in fact, we had started, but we are not doing it anymore. We had wanted to start working on mapping these Asian river channels, because I believe had it been we were able to achieve that, this will have changed the narrative in Nigeria. I believe so.
Thank you, sir. Okay, before I give, I think, okay, let me make also a little contribution on that, because I think that's my area actually. As a geophysics, that's my core. I've made over 85% good result from aeromagnetic. You know, like the question you asked him, it depends on what is your experience and what do you know about it. Can you process, what level of data processing do you know? Even in Landsat, even in ASTAR, you know, and using aeromagnetic and radiometrics, because they all differ. Landsat cannot give you structures in terms of, it can give you some lithological boundaries and all that, the surface and all that. But the aeromagnetic sits down, like what he said, there's a statement he made that tells me that, yeah, maybe based on his experience, because he said when he got there, he was in buildings. You cannot do interpretation and you go there, you see building, if you've done the real interpretation. You must know there's a building there. Do you understand? So, and some of the structures are not on the surface. You understand? Some are not really just on the surface. You might not really see them on the surface. So you need to integrate before you develop a lineament. Now, I will tell you that this is what most people do. They just draw a line and say, this is line, this is structure, this is... No, that's not... Most of the things you see people carry around are not structure. They are not actually real interpretation. When you marry out your radiometric, you process your magnetic into different derivatives. You bring in your Landsat, bring your ASTARs, band 1 to 14, depending if before you finish that, you do what they call real interpretation and processing. You cannot go to you must know where there are structures. If it exists, it will tell you. If it doesn't exist, it will not tell you. You understand? So this is the one. It's very, 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 in short, most of the work we've done even outside the country, we don't go there and start looking for the gold, whatever. We'll do all the whole processing from here and we'll move down there and we'll go there where we've not even done any geology before. You understand? And we'll start seeing things. So it is very, very useful, but it requires a lot of training and a lot of experience and all that for you to be able to do that. That is one. Then secondly, in terms of lithology, he's saying, I will say that when lithology plays a very good role in the sense that when you're talking about lithology, you're talking about rock property, which involves the porosity and permeability of a rock. For example, brittle quartzite gives you rise to gold than granite, because granite is not porous and it's not permeable. You know, that is one. Then in terms of talking about chemical reactivity, like what we say, carbonate rocks react, they are very reactive. They react more than others. So along that line, they can give out metal that can actually manipulate gold. So if the rocks are not reactive, definitely it will not. Then in terms of competence, some rocks can actually, like what Dr. said, in terms of when he was talking about deformation, some rocks can deform easily, some cannot deform. Some will deform in such a way that their lineations and parts can give you a pathway of fluid where fluid can actually trap, you know. So, and also that brings you to what we call lithological layering. If some rocks are not well layered, you won't see traps in them. So lithology plays a very good role and all that in terms of that. That's why you see some brittle quartzite and all that giving you rise to gold. I think that is it. On that, our time is almost up.
Well, you've learned a lot. I understand it's dependent on the expertise. Thank you.
Yeah. So
Thank you
I
very
think
much.
please, if you have more questions, you can actually submit our platform. We are still on. We can actually answer your question at any time. If you are not within the platform, you can look at some questions that have been sent. I mean, some links that have been sent by some of our main personnel. They can actually add you up, or you send them messages also. They can add you up and you can ask us questions or follow us on for some other things. So we actually do this once every month. Dr. Omar, we are very, very grateful for actually coming on today's occasion to actually share with us what most of us are actually enjoying right now. So thank you so much. We are very much grateful. And Madam, your hand is still up. So please, you might close by just thanking our guests here once again, so that we can all bring out our videos on, take pictures before we close. Madam, are you there to just say a word of thanks? So please, you can put on your videos right now. So we just want to take pictures while Madam actually closes. Okay, Madam, we're not hearing you.
Yeah, unmute me.
Okay, yes. Yes.
You've just done that. You've just done that. Thank you very much. Yeah, I'm so happy that our webinar went on well with what we had as in our Society for Economic Geologists last week. Let's continue doing this. I'm sure the young one must have learned from it. In everything you hear of geologically, there is entrepreneurship in it. It's just like what Dr. Omar have just said, that along the river valley, we have the ancient one and then the new one. That ancient one is where we should go and then think of how the flow of this water is. Do you have any geological identification of certain rocks? If you do that one, it means that you are already in it, and you can take somebody to there. The money, the people that have money will pay you. Don't worry. But that is the way to go about it, because employment is no longer easy for all of us that are geoscientists these days anymore.
You must know how to find gold. That is the only way you can make money fast. You must know how to find gold, whether you're a layman or a geologist. Because they can just go to this and make 1 gram. 1 gram is 190,000 naira today. Imagine you go and make 1 gram in a day. Every day you go and make 190,000. You come back. You know what it means? So what are you looking for? Who are you looking for? Again, 190,000 daily. You don't need to do for 2 grams or 3. Just get 1 gram. 1 is enough. Just come out of bush. And you don't need truck. You don't need anything to move there. But no, don't mine illegally. I'm not saying you should go and mine illegally. Look for license. Please put on your videos. And I want to thank some people that are actually here. I'm trying to see if they have a name that are new here. Dr. Ablahi, thank you for, I've not seen that name before. Thank you for joining us. Sevain, that name looks French. I don't know if I'm correct. Thank you. Mohammed, thank you. Gideon, I'm seeing my namesake here, Gideon Igwe. Interesting. Thank you. First time of meeting namesake in this platform. You must be the one to present next. And then Abdurrahim, thank you for coming. Of course, Ali, that name, I've not seen that. Thank you. Ridwan, Shew, you're also welcome. Austin, thank you for always being there. I see your comments everywhere, even on our Facebook. You always are very, very encouraging. You know, there is something I tell people. people will look at what you do. The first thing is that they look at where to tell you that you've not done it right. Meanwhile, they've never tried to even do one. You know, some of you are clamoring president, this and that. If they give you now a classroom teacher, it becomes a problem for you to even teach primary school and make sure that, you know, so these things we are doing is not, imagine leaving everything we have to do. See schedules. If I tell you how tight our schedules are, they will have to bring out 2 hours, doctor leave everything, all of us, you know, how many doctors do we have here? You know, I will tell you that we are not here just for, we are not here because we don't have anything doing. Everybody is very busy. But what we've tried to do, the legacy Madam Salawa actually led, is to ensure that we give whatever we have, let the young ones and all of us that are into the profession understand ourselves, and we can actually grow. So we appreciate everyone, your contributions, definitely, no matter however it takes, you know, make your contribution, whatever you have, throw it in. Christopher always contributes and also helped us here. Thank you, and I can see him is also present here. Clement Ayole, I think I know that name, whether I've seen that name before. So on behalf of IMSL group, please, I thank you. Ibu, thank you for your contribution. You always try to speak and say whatever as little as it takes. I take note of all those contributions. See, the issue is visibility. If you can't talk, you don't ask questions, nobody knows you exist. That's the simple truth. You understand? The only way we can understand that you are there is for you. Even if you don't know what to say thank you. I want to say something. Say, what do you want to say? Say, please, I want to appreciate what has happened today. It's enough. We'll see you. We'll see your face will appear. And most of you that always want to hide your face under the camera and all that, nobody will see you and know that you are there. You understand? Once in a while, tell us you appreciate what's going on. You actually done something, you know? So I thank you, and I said that you have a very great day ahead of you until we'll meet on our next webinar. Thank you.
Thank you. Thank you for the opportunity.